Okay, for question number 38 and 39, we are going to use remainder theorem or synthetic substitution, which in terms of the work procedure, they are practically the same thing. What it does is that instead of substituting the 6 into the x, we don't need to do that because that's going to drive us nuts. We can just go ahead and do synthetic division. And there's no missing term, right? No missing term. Yeah, we're good. And what remainder theorem says is that if we divide it, well, the remainder is our function value, in this case, f of 6. So we just have to make sure that we are doing our division very carefully and accurately. And then this is not 0. This is actually negative 24. Right, let me just double check everything is correct, right? 6 times 3 is 18, got negative 2. All the signs are taken care of properly. So yes, so we can say f of 6 is equal to negative 24. Okay, f of 6 is equal to negative 24. And then now we go to number 39. Again, there's no missing term. So 2, negative 9, negative 3, 12, and then we say what? We say 3. So 2 times 3 is 6, negative 3. Negative 3 times negative 3 is negative 9. Negative 9 times plus is this. Okay, negative 12 times 3 is negative 36. Minus, well, negative 36 plus 12, it's negative 24. So this too happens to be negative 24. Okay, so as you can see, it's really easy. Okay, it's really easy. It's more of the fact that you understand the meaning behind all the work that we're doing. If you say for these two questions in particular, if you say, well, you know what, I don't quite understand, then I would suggest you to go ahead and put in 3 into the x's, find out what the value is, and you should find out the same x value. And just for proving, if you say I want to see it faster, yeah, feel free, use a calculator, just insert the 3, make sure you type everything correctly, and you should get negative 24 as the answer. And that's how we say, well, you know, sometimes we don't we don't need to use a calculator, and we don't need to work with big numbers, and yet we can still get to the same answer at the end. And this is how I grew my appreciation towards the whole remainder theorem and synthetic substitution as a shortcut, and very efficient and effective shortcuts to get to our answer.